Hello there, Mr. Sutton here, bringing you the IM3 710 Extra Practice number 2 solutions on the other trig functions, specifically tan, secant, cosecant, and cotangent. There's a puzzle that goes with this one, so let's take a look at that. So for this puzzle, we're trying to unravel the mystery of who were the first people to invent a plane that couldn't fly. So we have to find the value of all these different trig expressions down below. And then once we find the letter next to the answer that goes with that, we put that letter above the appropriate number down here. So for example, let's say I do number 13 and I find that the answer is, I don't know, R. It probably isn't, but let's just say it is. So then I would put an R in spot 13 right here. So let's see what the actual answer to this riddle is. So here we go with the first problem on this. Now my strategy on all of these is going to be kind of the same. I'm going to try to get it down to either sine or cosine of a special angle, like 30, 45, 60, or 90, or something like that. And then I'm going to use my knowledge and memorized values of special angles to do the rest of the problem. So if I have something that's bigger than 90 degrees, I'm going to use my little unit circle here to rewrite it with a reference angle with the correct signage on the trig function. And if I have something that's not already sine or cosine or an easy value of tangent like tan of 45, then I'm going to try and use my identities to turn it into sine and cosine. And if I have something that is in radians measure, then I'm going to turn it into degrees if I can. So let's start this first one. Now this one we didn't have a lot to do before going to special values. We have sine of 45, which is one of our special values. That's radical 2 over 2. Cosine of 45, that's the x value at 45 degrees, is also radical 2 over 2. So radical 2 over 2 plus radical 2 over 2, we've got the same denominator, so we can now add the numerators together. That's going to be 2 radical 2 over 2. This 2 and this 2 are going to cancel out, leaving me with just radical 2. And now let me see if I can find that answer. I've got that next to the letter O here. So I'm going to put an O next to spot number 1 right here. And it looks like all these numbers are used only once, so I don't have to worry about duplicates. For the next problem, we have sine of 30 plus cosine of 45 degrees. Sine of 30 is another one of those special values. That's going to be 1/2. And then we already saw cosine of 45 on the last question. That's radical 2 over 2. Adding these together, they've got the same denominator, so I can move the 1 and the radical 2 into the same numerator, making it 1 plus radical 2 over 2. And I cannot combine those anymore, so let me hope that this is one of my answers. I see it actually right here on the left with choice E, so that's going to go in spot 2. 2 is E. For problem number 3, things start to heat up a little bit. We're working on our tan here. So tan of 60, that's not one of the values of tangent that I already have memorized. Like I know tan of 45 is 1. I don't really know much about tan of 60. So I'm going to go ahead and turn this into sine over cosine of 60. And then I'm going to figure out each of those individually. I know sine of 60 is radical 3 over 2. I just have that memorized. And then cosine of 60, that's another one you want to have memorized. That's 1/2. To simplify this fraction, because that's none of the answers over here so far, we're going to do same change flip, multiply by the reciprocal. So we have our numerator, radical 3 over 2, times, and now I'm going to flip this denominator to make it 2 over 1. These 2's are going to cancel, leaving me with radical 3 over 1, which is just radical 3. So that's just the tan of 60. I still have this minus sine of 90 to contend with. So let me bring my work down here now. I've got tan of 60 is radical 3. And now sine of 90, that's the y value at 90 degrees right here at the top of the unit circle. Since we're only going 1 in every direction, that means that I have a 1 for that y value. So this minus sine of 90 is really minus 1. Can't combine these in any way, so let me look to see if that's one of the answers. And it is over here, choice R, so 3 is R. For number 4, we've started multiplying trig functions together instead of adding them. This one, it turns out, isn't so bad, though. Sine of 30, we already saw, was 1/2. And now cosine of 90. Cosine is the x value. So I'm asking for the x value at 90 degrees. Since we're on the y-axis here, that x value is 0. So we have 1/2 times 0, which is just 0. And 0 is letter S, so then 4 is S. Things are becoming a little bit more challenging now with number 5. We have 4 times the sine of 60. I know the sine of 60, so I'm going to figure that out in a couple more steps and then just multiply 4 by that. But tan of 135 I don't know off the top of my head. So let me analyze tan of 135. Well, I don't know the 135s very well, but I'm going to make a reference angle with this. So the reference angle, 135 degrees, if you actually find the distance between that and the closest x-axis angle of 180, 180 minus 135 is 45. Now tangent is the slope of the angle. Slope is negative here in quadrant 2. So I'm going to rewrite this as negative tan of 45 degrees. Now tan of 45 by itself I happen to know. That's 1, because it's really just sine of 45 over cosine of 45, and those are both the same value. They're both radical 2 over 2. Dividing a number by itself just gives you 1. So then negative tan of 45 is negative 1 after all that work. Let me write some stuff down below now. Sine of 60 we saw was radical 3 over 2. So this is 4 times root 3 over 2, which I'll figure out in a moment. And then we have minus 3 times negative 1. Remember, tan of 135 was negative 1. So the 4 and the 2 here are going to cancel, leaving me with 2 radical 3. And negative times a negative is going to be a positive, so positive 3. Can't combine these, they're not like terms, but I do see that this is actually one of the answers, choice O, so we're going to put that in spot 5. For number 6, we have cosecant of 30 times tan of 60. Cosecant, that's the first time we've seen this one on this puzzle. That's really 1 over sine of 30. And sine of 30 we saw was 1/2. So this is 1 over 1/2. Multiplying by the reciprocal, I have 1 times 2 over 1, which is just 1 times 2, which is just 2. So that's my cosecant of 30. Now tan of 60 we found earlier on a problem from before, but I'm going to just do it again. So again, that's sine of 60 over cosine of 60. So radical 3 over 2 over 1/2. So root 3 over 2 times 2 over 1, multiply by the reciprocal. And then again, the 2's cancel, leaving us with just radical 3. So bringing all this back down here, cosecant of 30, that was 2. Tan of 60, that was radical 3. 2 times radical 3 is just 2 times radical 3. Not much you can do there. So that is one of the answers. That's R, which is going in spot 6. On this next one, we've got secant of 120 times cotan of 225. I'm going to figure these things out individually, and then I'll just multiply them together at the end. So secant of 120, let me first get a reference angle for that. Now secant is just the reciprocal of cosine. It's going to behave like cosine in terms of positive or negative. 120 is in quadrant 2. That's negative x values, negative cosine values over there. So when I rewrite this with a reference angle, I'm going to end up with a negative. Now 120 right here is 60 degrees away from 180. So that's our reference angle. We've got then negative secant of 60 that I can rewrite this as. Now I can also rewrite this as negative 1 over cosine of 60, because that's really what secant is 1 over cosine. And I'm going to do that because cosine, I know that value, cosine of 60, that's 1/2. So this is really negative 1 over 1/2. Which is really negative 1 times the reciprocal, 2 over 1, which is really negative 2. So that's what secant of 120 is. Now cotan of 225, I'm going to do the same kind of thing. Cotan is the reciprocal of tan. So it's going to behave like the slope of the angle when we're talking positive or negative. 225 is down here in quadrant 3. The slope down here is actually positive. It's moving up and to the right if you were to draw that angle. So this is going to be a positive when I rewrite it with a reference angle. And 225 is 45 degrees away from 180. 225 minus 180 is 45. So I can rewrite cotan of 225 as positive tan, or rather positive cotan of 225. Now I'm going to rewrite this with tan though. I can rewrite this as 1 over tan of 45. And tan of 45 is just 1. So this is 1 over 1, which is just 1. So putting it all together down here, we've got negative 2 instead of secant of 120. We have 1 instead of cotan of 225. Negative 2 times 1 is just negative 2, which gives me letter H here. So that means that 7 over here is H. So at number 8, they've decided to throw one more wrinkle into the mess here. Now we have radians instead of degrees. Now you could try to figure everything out in terms of radians, and that's fine if you can work well with those. For my part, personally, I really prefer working with degrees because when I'm getting reference angles, it's much easier for me to add and subtract things with just degrees instead of messing with these fractions with pi's in them. So, turning these into degrees, remember we're just multiplying by 180 over pi, so basically doing 180 divided by the denominator and then multiply by whatever non-pi stuff is in the numerator. So pi over 3, 180 divided by 3, that's 60 degrees, so sine of 60. And then 180 divided by the 6 here gives me cosine of 30 degrees. And these are special values I already know. Sine of 60 was root 3 over 2. Cosine of 30 was also root 3 over 2. That adds up with the same denominator to be 2 radical 3 over 2. 2's cancel, so that's radical 3. And radical 3 is letter n, so 8 down here is n. For this next problem, we're going to convert these to degrees here. So pi over 4 is going to be 80. 180 divided by 4 is going to be 45. So tan of 45 degrees plus cotan of 45 degrees. Now, tan, I'm actually going to analyze this in a second. Tan of 45 is a special value, I know. But cotan of 45, let me express that with tan. So that's really 1 over tan of 45. And now tan of 45, without any further ado, that's 1. Plus we have 1 over 1 here. So basically 1 plus 1, which is 2. And I've got 2 for letter R, so we've got R going in the 9 spot. Here we go with number 10. This might not be the last problem, but it could have qualified for the final boss battle. There's a lot going on with this one. Let's start by turning these into degrees. So 180 divided by 3 is 60, times 2 is 120. So we have 3 cosecant of 120 degrees, plus now we have 180 divided by 6 is 30, times 5 is 150, so sine of 150 degrees. And let me get some reference angles out of all this. Cosecant is like sine, the y value of the angle, in terms of plus or minus. 120 is over here in quadrant 2, so this is going to be a positive value for this. And 120 is 60 degrees away from 180. So I can rewrite this as positive 3 cosecant 60. And again, this is going to be positive instead of negative because this behaves like sine because it's really 1 over sine in terms of where it is. Y values are positive up here in the second quadrant. Now speaking of y values, we have sine itself here of 150. That is still second quadrant. 150 is 30 away from 180, so we have a reference angle of 30. And again, because sine, the y values is positive up here, we can rewrite this as just positive sine of 30. Okay, now I'm going to turn this cosecant into 1 over sine, so I'll rewrite this as 3 over sine of 60. And sine of 60 is going to be radical 3 over 2. So I have 3 over all that. That's going to be a little bit of a mess. And then sine of 30 is just 1/2, which isn't too horrible. I'm going to clean up this first fraction quite a bit before I do anything else. So let me multiply by the reciprocal. 3 times 2 over radical 3. So this is going to be 6 over radical 3 plus 1/2. And I could try to get a common denominator, but I know that I'm going to have to get rid of that radical in the denominator down the road anyway, so let me do that now and not worry about it later. So I'll just multiply this by root 3 over root 3. That's going to be 6 radical 3 over 3 plus the 1/2 there. 6 divided by 3 is 2, so we have 2 radical 3 over, just 2 radical 3 plus 1/2. But I'm actually, another way I could do this, I'm going to take that back. Instead of reducing this right away, I thought of a better thing I could do. I'm going to get a common denominator, move everything together, then I'm going to reduce. That way I don't have to run the risk of reducing, getting a common denominator, combining, reducing again. Let me just get everything together as soon as I can. So a common denominator from 3 and 2. Smallest number that they both go into is 6. I can make this first fraction have a denominator of 6 if I double the numerator and denominator. So this will be 12 radical 3 over 6. And for the 1/2, to make that over 6, I have to multiply by 3 over 3. So that's going to be 3 over 6. And now if I combine these together, I'm going to end up with 12 root 3 plus 3 over 6. Before I do that, because I'm kind of out of space though, at the same time I'm going to reduce everything by 3. So 12 radical 3 reduced by 3 is really 4 radical 3. 3 reduced by 3 is really a plus 1. And 6 reduced by 3 is really a 2. So instead of writing 12 root 3 plus 3 over 6, I just reduced everything by 3. And I'm hoping that's an answer. It looks like it is. That's B. So after all that, I get B for 10. All right, feel free to take a moment if you're still recovering from number 10, but we're on to the next one here. So getting these in degrees, 180 divided by 3 is 60, times 5 is 300, so sine of 300. And this is just pi is 180 degrees. That's the direct conversion there. So this is just tan of 180. Reference angles now. 300 is here in quadrant 4. It's going to be 60 away from the 360 line, which is also the 0 line. So reference angle of 60. Sine is the y values. That's negative down here below the x-axis. So negative sine of 60 is how we can rewrite that. And then tan of 180, I'm actually going to leave it the way it is because that's one of my 4 major quadrantal angles. So I can figure that out without any kind of reference angles. All right, so sine of 60 we know is root 3 over 2. So this is negative root 3 over 2. Tan of 180. So here's 180, this left line here. That's asking for the slope on that line. If I drew this angle, that would be a slope of 0. So this is just plus 0. Which means all of this just comes out to negative root 3 over 2, which is t right here, so that's going in spot 11. And I see the word brothers. Okay, interesting. Let's keep going. For number 12, let me get all this in terms of degrees before I do anything else. So this is secant of 180 minus cosecant of 180 divided by 4 is 45 degrees. Now let's turn these into something with sines and cosines. Secant is really 1 over cosine of 180. Cosecant is really 1 over sine of 45. And I actually can get these values, cosine and sine of these numbers, right away without using reference angles. Cosine is the x value, so the x value over here at 180 is going to be negative 1. So this is 1 over negative 1. Next up, sine of 45 is root 2 over 2. So this is 1 over root 2 over 2. Now using a same change flip, we really have 1 times 2 over root 2 that we're subtracting there. And now multiplying by root 2 over itself, this is 2 root 2 over 2. And then finally these 2's are going to cancel, leaving me with just a minus root 2 there. We still have that negative 1 out in front as well. So that all comes out to something that matches letter W. So that's going in spot 12. For the last problem, this one could be a little bit tricky. We've got pi over 2, which if you divide 180 by 2, that's 90 degrees for both of those actual angles. Cosecant is 1 over sine of 90 there. And cotan, I could write this as 1 over tan of 90, but I'm going to tell you why I'm not going to do that. Tan of 90, that's the slope. If I have a vertical line going through 90 degrees, that's an undefined slope. So I don't really want to be in the position of writing 1 over undefined. I don't even know what that is really. So instead I'm going to use the other way of expressing cotan, which is cosine over sine. Because cosine and sine are both defined at 90 degrees, whereas tan is not. So converting these to special values, sine of 90 up here, that's the y value up there, that's 1. So we have 1 over 1. Cosine of 90 is 0. That's the x value there. Sine of 90 again is 1, so this is plus 0 over 1. So we basically have 1 plus 0, which is just 1 after all that. So that's G going in spot 13. And now we can solve the riddle. Who were the first people to invent a plane that couldn't fly? Not the Wright brothers. It is the Wrong brothers. Oh, I see what they did there. All right. Well, I gotta fly. Time to jet. Mr. Sutton taking off here.